So today's agenda, we're going to be discussing golf turf winter dormancy, and the goal is to unlock winter resilience with advanced microbials. So I'm going to explain to you how you could potentially use microbials. So we're going to discuss microbials for grass maintenance and turf microbiome research to date. So I'll give you a little bit of an overview of that. I'm also going to discuss microbes and winter dormancy, definitely the subject you're all here to listen to, and also how to optimize winter resilience. So how can we get grasses to do well over the winter and in the spring to grow quickly? And then finally, I'm just going to give an overview of our commercial trials, some of the results that we have. Okay, so microbials are definitely something that the turf industry could consider as an alternative, as a treatment for grasses. Microbial inoculants are gaining a lot of attention as biofertilizers. I've been working with them in crops, and they're very successful at increasing crop production and plant disease resistance. So due to that success, recent studies are now starting to look at microbials for turf grasses for improved growth, stress resistance, and also for disease reduction. And microbials demonstrate a lot of success at reducing fertilizers and fungicides, and also they increase growth and nutrient retention on grasses all at the same time. So definitely something that is gaining a lot of attention in research. So here, this figure, I'm just trying to give you an idea of what the grass microbiome is like. So we all have a microbiome on the inside, and that's sort of new in the last, I guess, I don't know, maybe 20 years of research. And for a while, plants were considered sterile on the inside, and now they're not. Plants have spheres, so they have an upper section here, which is called the phyllosphere. There's a lot of sort of research that had been done on the rhizosphere. That was sort of the first zone of research that began in microbials for plants. And most importantly, plants have an endosphere. So the endosphere is like our microbiome. It's on the inside. And this is where microbial inoculants that target the endosphere would work. And that connects all the way from the roots. So here you see a root cross-section showing bacteria that colonize the inside of the plant. And those can, in turn, colonize the stem and go throughout the plants. For grasses, that would be tillers, crowns. They would be going through the entire plant. So grasses and plants are constantly internally colonized. They've always been, and they've evolved with bacteria. So the microbiome inside grass, like I said, is called the endosphere. So this is important for us because those are the microbials that we're discussing today. So these bacteria reside inside plant tissues, and they are called endophytes. So the grass endosphere is very well connected. So if you inoculate your plant, then you're going to likely find that early inoculations will result in bacteria traveling from the roots all the way to the leaves. If you inoculate the phyllosphere in a young plant, you'll see the reverse happening. And there is just a complete overhaul of colonization that's happening throughout the plant. So it happens from roots to tillers and even in the stem. These endophytic bacteria can move within the plant tissues, like I said, and grasses need those endophytes. So they have a network of endophytes that they evolved with and they're working with. They need those endophytes to convert nitrogen, iron, and phosphate to usable forms. So the plants can't do that on their own. They actually utilize bacteria solely for that purpose. And they also need them to combat drought and stress. So without endophytes, they're unable to do that. And so although the plant has its own endophytes, sometimes it has a limited supply. So adding an additional layer of inoculants to that plant is going to definitely reinforce the plant, give it plenty of resources. Just like our microbiome, like if we're dealing with antibiotic resistance, it's the same sort of thing. You need to reinforce that plant's microbiome to help it to be as healthy as possible. So one of the ways that plants combat drought and stress is by producing a very important enzyme called ACC deaminase, which I will explain further later. And also, this creates an overall growth promotion in the plant. And this strengthens the whole plant And of course, during active growth, when you inoculate your plants, they are readily absorbed throughout the plant. So I did a little bit of look into some of the research regarding grasses, and there's a lot of interesting things that are just starting to happen now because of the success in crops. So in 2020, there was very interesting research on bench grass, and this showed that grass tillers with endophyte treatments grow 36% more than untreated controls. So both of them were fertilized, but you saw a 36% increase. And then in 2023, this study I really liked a lot because it went quite deep. This is in crop science. So this is what I'm showing here. Everything with the dots on it is the inoculated plant. So really just focusing on that, you can see that no matter what this is explaining, you're seeing an increase in plants that are inoculated. So this particular study showed that endophytes were producing ACC deaminase, and they wanted to see the link between ACC deaminase and drought recovery in creeping bentgrass while promoting growth during the drought. So they had a drought for 35 days, and then they did 15 days of watering. So what they observed was during the drought, they found that grass crowns had a particularly high accumulation of sugars that were promoting tiller growth. And this was not happening in the controls. And if it did happen, it was definitely on a lower scale. During drought and after rewatering, during both of those times, they saw an increase in tiller numbers, rate of production, root growth, length, and also number of roots. So they saw rapid regrowth during and after drought. And what they noticed was that ACC was elevated in the plants that were not inoculated during the drought, and that was reducing the growth so that the ACC deaminase was actually reducing ACC in plants that were inoculated. So again, low ACC compared to controls. And then another study just this year also showed the inhibitory effects of microbial inoculants. Again, these are endophytic bacteria. And these inoculants were able to reduce the growth of dollar spot. So here what you see is an inoculant. This is like a little disc that has the inoculant on it. And then it starts to grow sort of out in this area here. So wherever it's grown, you can see that dollar spot is inhibited. So this is really important for inoculation science for grasses. Okay, so what does this mean for winter dormancy? Just going to click here. Okay, so winter induces a drought-like condition. It's mild and it signals grass dormancy. So that's a necessary drought condition. However, there is additional drought stress that can happen beyond dormancy. And this is where sometimes you might see your grasses are affected. Things like frozen soil, limited snow cover, or slower root growth during the winter. And also things like winter desiccation. So your grass might lose more water through leaves than it can replace. Also, what happens is this will signal stress in the plant. So you'll get this ethylene production, and that ethylene production will limit nutrient uptake and will slow down growth. And this is what you don't want. So endophytic bacteria can combat winter drought stress. And the way that they do that is, if you look over here, I've got a list here of all the things they can do. I won't go over all of that, but probably the most important takeaway is that they synthesize ACC deaminase, which sort of tricks the plant into thinking there's no stress. And so the plant then will continue growth, continue nutrient storage. It will lengthen those roots, reach all of that water that it needs to reach in the winter. And it just keeps the plant in an active state and functioning in a way that is much more beneficial for growth, especially for the spring. So there are structural adaptations that grasses have for the winter. So specific structures where they store nutrients. So for example, grasses store sugars and nutrients needed for growth in these structures. So very specifically in roots, also in stolons and tillers, and also in crowns. So we kind of mentioned that, I mentioned that earlier in the 2023 study. So endophyte treatments also, what they do is they reinforce these structures and their function for an improved winter resilience. So because it's lowering that stress, these functions can keep going at a consistent rate. So for example, in the roots, they're active all year round. During dormancy, they are a little slower, but under stress, they will shut down quite a bit, all of their growth and lengthening. However, if they're inoculated, then they're going to store water, they're going to store sugars for periods of stress and drought, and they store nutrients. Specifically, they store excess nitrogen over the winter, and this is really important for the spring. As this nitrogen is the only source that is used by stolons and tillers in the spring, which I will go into a little bit later. The crowns are also very important. They store excess carbohydrates for faster spring green-up. Stolons and tillers will increasing these during the season and making sure you have a lot of growth after inoculation will improve your nutrient storage, will improve transport, and again, speed up growth in the spring. Okay, so having a steady growth is what really is important through the winter to have that winter resilience and stress reduction. So what happens is the plant specifically partitions these nutrients for winter resilience. And a journal of plant nutrition, there was a 2017 study that showed that grasses use nitrogen primarily for roots, as well as rhizomes in the first 10 days of spring green-up. In fact, it was the sole source of nitrogen during that time. So this is really important. There was very little uptake by roots or by the tillers and the stolons from fertilizer until about day 10 to 14 after the first tillers. So adding nitrogen too early in the season before spring green-up, in this case, ended in the water supply with only about a 13% uptake. And what they did is they compared winter roots to the growing roots that were fertilized with nitrogen, and they showed that the winter roots had a much higher nitrogen concentration compared to the fertilized new roots. And fertilizer then, again, was only taken up around day 10 to 14. So endophyte treatments are really important because they're going to, again, fortify your plant. They're going to increase nitrogen fixation and storage. So they will do that by increasing growth. And while they're doing that, then your roots are going to increase in numbers and length. It's important to fortify that in the previous season to increase nitrogen storage. So this particular study really highlighted the importance of the previous year's storage ability to keep roots long and full of nitrogen because that is your first source in the spring green-up. So grasses also store carbohydrates and sugars. They also need that nitrogen for the regrowth in the spring, which I already mentioned. And the endophytic treatments are going to reduce ACC to normal levels so that you can increase that growth, increase that storage during drought or any kind of stress. And then you're going to have an increase in nutrients and a faster post-stress growth. So I'm just going to recap then, how do endophytes fortify grasses for winter resilience? So throughout the season, regular microbial treatments will reduce your plant stress. So that's key because plants undergo a lot of stress. They undergo it throughout the season as well as especially during the winter. And so you want to use your treatments to optimize plant growth. So you use it in the spring, in the early growth, to initially get that colonization happening because new growth will get colonized by endophytes a lot faster. So in the spring, that's where you want to put your first treatment. And then you want to also help your plants cope with summer drought stress resistance. You want to make sure that you're lowering that ethylene response to stress and get that plant into a state. This way your plant is functioning properly and not active, sort of reducing its growth because of stress. You're also going to be then having a plant that is able to resist pathogens. And then your overall goal is to reduce stress the entire season to increase that growth. That will give you an optimal winter resilience. So to increase pre-winter nutrient retention for an optimal spring green-up, the things to focus on are increasing your root mass length to provide nitrogen storage in those first key 10 days of spring, and also to improve nutrient storage in the crowns and tillers. So this is really important to inoculate your plants in order to fortify them so that they're not affected by stress and they can work on doing that. You also want to increase the number of stolons and tillers. And again, that's all related to fortifying your grass to resist stress so that all growth is happening quickly. And additionally, endophytic bacteria also increase growth. So if you remember in the previous slide, I mentioned a 2020 study that showed an increase in tillers by 36%. So you're going to see that endophytes not only protect from drought stress, but they're also increasing the growth quite a bit in your plants. Okay, so now I'm just going to go over our internal trials. So here at Earth Microbial, our chief of R&D, Patricia Dorda Quadros, did quite a bit of experiments on different crops, including turf. So here you can see there's a control turf here. I believe this is a mix of blue, I see it here, blue fescue and rye. And so the control had a little bit of trouble. This was not fertilized. And then here you see the N turf. It has an obvious increase in chlorophyll. We can tell by the green color. And we can see that there's an increase in nitrogen fixation. So we did this in 2022. And what we found was that N turf increased grass dry weight by 121%. So it was pretty dramatic. You can see here in the graph N turf, and these are the controls. The grass was greener. So we know that greener grass means that chlorophyll is increased, and we've also tested this chlorophyll link to nitrogen fixation. So we know nitrogen fixation is increasing. We also did additional lab tests on our strains, and we see that our strains produce ACC deaminase enzymes. So they will help combat stress. They produce hormones called cytorophores for iron absorption. Plants sometimes have a difficult time accessing iron, so endophytes help access iron. And also, they solubilize phosphate for phosphate absorption. And most importantly, for your spring green up and that stored nitrogen, they will fix atmospheric nitrogen and turn that nitrogen into ammonia for absorption by your plant. Okay, and then at the beginning of this year, we also did additional trials. I believe this is on Kentucky bluegrass. And again, N-turf outperformed the controls for dry weight. There was a 160% increase. These were fertilized. So both of them were fertilized, and you can see that N-turf was able to utilize nitrogen a lot more and increase growth. I'm going to show you a picture in the next slide where we see that the root mass increased. Both treatments, like I said, they were fertilized, and these results we have seen repeatedly in other crop trials with increases in chlorophyll that were directly correlated to nitrogen fixation. So we are planning to do future trials, and in those trials, we will test 3 fertilizer levels along with a control to determine fertilizer reduction, how much we can. But we have seen other crops that we've tested in our internal trials reduce fertilizers by 25% while increasing growth beyond the control, and we expect to see similar results. So here is the 2023 trial on Kentucky bluegrass. You can see here the control, not a lot of roots growing here, but here in the inoculated version, there's an obvious increase in roots. You should see quite a bit of a mass of roots here and down here. So this is really, really important for that nitrogen fixation and increasing sugars, carbohydrates, and water retention. So just to recap, what is your end game? So your end game here is sustainable practices for winter resilience. So how do we do that? Endophytic microbial inoculants can improve your winter dormancy and your spring green up. They reduce ethylene buildup, so that's stress. That stress is caused by drought. Also, I read some studies about foot traffic also inducing ACC buildup in plants. And so ACC deaminase is vital for reducing that stress. There's going to be an increase in available nutrients like iron and phosphorus. There will be nitrogen, and that will reduce fertilizer use. And of course, there is an overall plant growth promotion of tillers, stolons, and roots, and that increases your nutrient storage over the winter, which is really important. And also root length and numbers. And again, this is a maximum nitrogen storage and water access for winter recovery that you'd be looking for. and also pathogen defense. And of course, your end result is going to be a greener and healthier and winter resilient grass. So I hope you enjoyed my talk, and I think I'm going to turn it over now to Q&A. So I'm not sure, Drew, if you're going to be taking that over,
Yeah,
or
sure.
Matt Albert. Sure.
I thought that was, Patricia, excellent. Thank you so much for that information. It's always so interesting to just see all the different components, and I just really enjoy you know going further through and going deeper into the science behind microbials. So that was really an excellent overview. Thank you so much. So we're going to turn it over to Q&A. I'm sure everybody on the call has questions or would may want deeper answers. So let's start with the first question that came in here about how do microbial inoculants affect the existing microbial communities in the soil. So I'm going to open this up for Albert, I think I might give you first dibs on that if you want, and then if you need to turn it over to Patricia or Trevor, just please pull them in, and we'll go from there. And you may be on mute right now, so David, you may need to unmute Albert.
Thanks, Drew. Yeah, I think this is a good question for our head of science and research, Patricia, or our chief science officer, Trevor.
Sure. So Trevor, do you want to take that? And David may need to unmute Trevor so he can answer it.
Hi, everybody. Not sure if you can hear me.
Hopefully we can hear you fine, Trevor.
Okay.
Loud and clear.
Yeah, that's a really excellent question. One of the things to realize is that soils are the most diverse microbial community anywhere on Earth, and that includes the soils and turf. And so it's a big challenge to really remodel the microbial community in those soils. And we often see that when we add microbials as inoculants, one of the big challenges is for them to actually compete with the other microbes that are already present in the soil. And so for the inoculants that are present in these products, what they do is they actually associate closely with the plant. There's not really much evidence that they do change much the overall microbial community in the soil, but what they'll do is they'll enter into the plants and set themselves up as endophytes, right? So that they're intimately associated with the plant. The plant is providing them with resources so that they can live and survive and proliferate and provide all that benefit to the plant. But current evidence is that they are not really changing too much the overall microbial community in the soil itself.
Fantastic. Tanya, I hope that answered your question fully. Not sure if you have any other follow-up questions from that, but that was an excellent question. All right. One other question that I had been asked by one of the participants prior to this had been, Albert, I'm not sure if you can just give a little bit of information on the courses that Earth Microbial is working with right now, and sort of just give us some background on who's been applying the product and some insight there.
Sure, Drew. I think a couple of things to I just want to kind of point out, because I think one is that we're really excited about what we're seeing, not from just a research perspective, because our team, again, Trevor's our chief science officer. He's also the head of the Waterloo Center for Microbial Research. So on the agriculture side, where the lion's share of our research, study, commercial trials, working with greenhouses and growing crops, and bringing that over to the turf grass side is where we were very excited. So I think that what we're seeing is that taking the research to controlled environments to really see the science and the microbials in action, and then taking it to actual golf courses in the field, where now you're dealing with, again, just all the additional variables of what's already in the soil, the environment, the temperature conditions. And I think that over the last, I'd say the last year, more so this year, we had some pretty significant results, especially in the areas of pathogen resistance and dollar spot. And I think we were pretty excited about the results that we saw over at one of the courses in London, Ontario, the Oaks Golf and Country Club. And there they had treated a 2.5 acre practice area where they were able to, where they don't lay down any fertilizer, any treatments, and they had inoculated that area. And that area includes greens and fairways, and you can see that picture there. So it's just a pretty great, a large area. And this was also an area that the superintendent had described as always getting dollar spot. So I think the results after they inoculated in March and April earlier this year, when he came back, and we got some video that we're happy to share as well. But the no dollar spot had appeared. He had felt that there was an improvement in just the overall look and feel and the health of the grass. And I think during that time as well, they had gone through a drought period, and the way the grass had recovered. Again, he was very happy with how that went. So he's taken it over at the Oaks to the next level, where they're now inoculating all 18 holes, about 30 acres of area, to inoculate in September and October to prepare for the winter. So the microbials will be inoculated and established within the grass going into the winter. In September, they slow down a little bit. So he had shared that he's going to just not apply any fungicides to a couple of holes, just to see that in action as well, to see how those holes will respond. And we're pretty excited to see how that will turn out. And I think that overall we're just seeing that's probably the most comprehensive large scale application that we've seen from a golf course over 30 acres and 18 holes. So that being said, I think that we have numerous trials ranging from the West Coast in the U.S. We've had trials at TPC Harding Park, Wiltshire Golf and Country Club in LA, right through to trials in the Eastern U.S. And I think there's probably 15 or 20 trials that are in progress or about to start in the southwestern Ontario region and Ottawa as well. So I know it's a long answer, Drew, to your question, but I think that there's
no, but I think
a lot of activity.
Yeah, and you brought up a number of really good points. So one of those segues into our next question that just came in, which was, can you share more details in the application process, and if there are any preparations that they need to make prior to applying the product, and maybe Albert just give a little bit of information around safety and and talk to some of the benefits of using microbials over maybe existing incumbent products that courses may be using.
Yeah, for sure. I think our microbials and our products are actually designed for agriculture. So we are EcoCert certified, which is a very significant certification for demonstrating being an organic input for agriculture. So we're also registered with the Canadian Food Inspection Agency. So this is safe for use. Our microbials are safe for use on on food. So when it comes to applications on turf grass, again, safe for use. I think that we've heard back from our superintendents that we've been working with over the last few months that one, we know that it's complementary to your existing treatments, because again, some treatments will target for example, the roots and the maybe like trichoderma or like bacillus treatments may treat the phyllosphere around the plant. But adding in our treatments, which are endophytes inside the plant, is a significant boost, right out of the gates. And from there, they start looking at reducing fungicide use, reducing pesticide use to get some of the cost savings and just overall benefits. I think from an application standpoint, we these are beneficial bacteria, so we recommend and we try to avoid extreme heat. When the product's received as a liquid concentrate, so it's diluted at about 1 part to 300, we recommend an application, a topical or foliar application. So just be sprayed on like you would a fungicide or your other treatments. And I think that there's some nuances where we're looking to work with the specific golf course superintendents to figure out how to optimize the uptake and establishment within the plants. And I think that, again, we're doing some different studies for, let's say, like in Scottsdale, Arizona, where we're dealing with desert and heat, extreme or very high heat conditions, which is very different from how the microbials establish themselves in, let's say, the cooler climates like New York and Ontario and Chicago, or Illinois. So I think that from an application standpoint, we just try to make it really simple. Start with what you've already got, apply it on top. You can't over apply it. It's safe for use. Your dogs can run over it right away, and it's again, it was designed for food safety. So it's safe. And two, as you feel comfortable for your course, whether you want to apply it to greens or fairways, or you want to just target a 3 to 5 acre area that areas around the course that are known trouble areas for either drought stress or pathogen, dollar spot anthracnose. We just, wherever the superintendent's comfortable trying and starting out and applying, and then kind of taking it from there. And we're really looking for opportunities to partner with these superintendents, because we want to learn how we can continue to optimize, again, the uptake and kind of like the what we're seeing in controlled environments into their real world courses and their specific environmental conditions at their course.
And just to ask you one other thing, Albert, like when they're using the sprayers, when they're using, putting the product into the ground, can they mix it in with other products? Is there a method that we prefer in terms of how we want to see the product applied to large areas?
Yeah, I think this is an area, the actual application. Again, we're very focused on delivering pure, microbial. So very, very high concentration. It's pure. So we recommend spraying it on its own. So diluting and spraying it on its own without mixing. Now we're looking to do more testing around compatibility with other treatments. So like, for example, we're pretty comfortable mixing with fertilizer treatments. Maybe with fungicides, we're not so comfortable, but I think that, this is an area that we really want to work with superintendents to continue to figure out and optimize. And, our goal is to make it as easy to integrate into their existing programs and treatment and application methods as possible.
Excellent. Thank you so much for that. All right. So I know we wanted to keep this webinar to 1:40, 1:45, and I want to be respectful of everybody's time. The final slide that you see is really for your purposes to follow up with us. If you have any follow-up questions, if you want the recording, if you would like to talk with us, please go ahead and use the details that are on that slide. So you can either call that number 949-490-0208, or you can follow up with a email to info@earthmicrobial.com. We are extremely accessible, extremely responsive. We love feedback. As we mentioned during the webinar, we are looking to collaborate with groups and to get your feedback as well. So please do reach out. The phone number's there, the email's there. You can reach out to any of us. We will follow back up. This will be recorded and has been recorded, so we will be able to provide a link to this, so you can go back and watch any piece. So if there was a section that we ran over quickly, please go back in, have a look at that, and make sure to follow up with us if you need to with any questions you have. Finally, there is a survey link at the end of this as well that will come out, and we hope to do some additional education webinars in the future. So we hope that you'll attend those as well. I think there's always a lot that we learn and gather from this, and we also learn from the feedback and questions that we get from everyone who attends. So it's been fantastic. Again, thank you to Patricia, thank you to Trevor and Albert, and everybody who has attended today. Appreciate your time, and we will wrap it up at that. So thanks all.